would like to present you with a tutorial video that I've prepared for you on how to model pedestrian flows in Aimsun Next. Pedestrians are, of course, yet another important piece of the transportation puzzle. They do interact with public transportation services. They might conflict with other road users as individual cars or bicyclists. Today, I would like to present you with tools and few tips and tricks on how to model pedestrians in our newest product, Aimsun Next 20. This should help the city planners and decision makers to make more qualified decisions in terms of managing flows of different route users. So make yourself comfortable and enjoy the video. I have my Aimsun X20 model opened in front of me. So let's switch from the news page into tutorials and let's locate the simulating pedestrians tutorial. Already here you will find a short content about this tutorial, and below in the documentation you can find more detailed information about every modeling step. Next you can see that there is an option of initial and finish network. Today we'll be working with the initial network. However, if you want to cross-check the results of your work against our pre-simulated scenario, then you can do it with the finish network. Let's open the initial network and choose the destination folder for our model. Once Aimsun Next has loaded the scenario, let's spend a couple of seconds investigating the network. So we see a rather small sub-network of the Barcelona road network around Camp Nou stadium with a number of sections, nodes, and roundabout, and few centroids holding the origin destination information. Today we are going to be modeling pedestrian flows. For that we need few pedestrian objects. These are stored on the left side of the screen. So we see the pedestrian area, decision node, and a few other objects that we will be talking later on. Let's start with creating a pedestrian area. Pedestrian area is essentially a polygon. So we can draw a polygon and the desired location and finish the polygon with a double click. Once we have drawn the polygon, a new layer called pedestrian layer will be created in the layers tab. If we investigate the layer further, we see it is already holding a pedestrian area object. It is a good idea to separate the different objects in the model into different sublayers. And that's why we are going to create 3 sublayers within the pedestrian layer. And let's call them area, bridges, and finally centroids. To move an object into a sublayer, right-click on the object, select Arrange, move to Layer, and then locate desired layer. So here it is, Area. It can be a good idea to disable editing of some of the sublayers, not to make any undesired changes. So in that case, right-click on the desired layer and disable Allow Object Editing. This will prevent you from doing any undesired changes on the polygon. Our next task is to create pedestrian demand, and the concept is similar to the motorized traffic demand. We are going to create origins and destinations of pedestrian demand by means of pedestrian entrances and exit objects. So first, let's activate the layer Centroids so that all future objects are going to be placed in this layer. By selecting creating pedestrian entrance, I can place the first object right next to the metro station. And let's call this Metro In. Next, let's move to pedestrian exits. And here I want to notify you that by double-clicking on an object in the toolset, you can create multiple objects in a row. If you want to edit, move, enlarge the objects, simply select them and move them to the desired location. Now let's rename those objects as self out and as camp now out. So far we have modeled pedestrian area, pedestrian entrances and exits. Now it will be the time to look into the structure of the pedestrian origin destination matrix. We see that in the project app there has been already a pedestrian centroid configuration created for us. But before we create a pedestrian OD matrix, let's take another step and define a pedestrian type. Pedestrian type helps us to distinguish between different types of pedestrians, such as commuters, tourists, and so on. In this step, we are exposing a number of parameters, and it would be great to have a solid overview of what these parameters are and how to interpret them. In Aimsun Next, we have implemented a faithful representation of the social force model by Dirk Helbing. And the social force model models the repulsive and attractive force of each pedestrian agent. So first, let's talk about individual parameters for each pedestrian type. You can define the walking speed with its deviation, min and max, as well as the radius, which is basically the diameter of the pedestrian agent. Beneath are the type parameters for each pedestrian type. So the attractive force is here represented by the driving force, which is split into 3 different modes. So the pedestrian agent can either be waiting, walking, or running. Waiting is the situation when the pedestrian agent is waiting, for example, for a bus or before the light turns green. Walking is the most common pedestrian movement, while running is in the situation where the pedestrian agent is crossing a pedestrian crossing or pedestrian crosswalk and the traffic light turns red. The relaxation time expresses the acceleration, but also the aggressiveness. So the shorter the relaxation time, the more pushy the pedestrian agents will get. Below you will find parameters of the social force and obstacle force for both walking and waiting. The interaction strength affects how quickly the exerted force decreases with distance. The interaction range determines the influence of distance on the repulsive force. And last but not least, anisotropy of interaction. It's a parameter that represents an effective field of view of the pedestrian agent. This takes a form of a dimpled limaçon, and I would encourage you to look up the math behind this model and also the shape of the field of view of a pedestrian agent. You can change the parameters here. We advise you to do this carefully, and you can experiment, for example, with currently applied social distancing rules by setting different interaction ranges and interaction strengths. So let's keep the default values for the moment, but let's head to the 3D Shapes tab and let's add 3 different 3D models for pedestrian female, pedestrian male, and a child. Adjust the percentages so that the percentages adjust sum up to 100. The next step is to define origin destination demand for pedestrian flows. To do that, we right-click on the pedestrian centroid configuration and choose a new pedestrian OD matrix. In the main tab of the pedestrian matrix, there's a number of settings that we can adjust. So for example, change the matrix name to pedestrian matrix, the clock with a duration of 1 hour and adjust accordingly, and change the pedestrian type to commuters and leave the rest of the settings as default for the moment. Under the cells tabs, we are then encouraged to enter few OD flows. So let's come up with some example numbers, and that's it. Now we have defined the demand for this simple OD matrix. Let's proceed. We can spend a few seconds on how do pedestrians find their routes in the network. So within the pedestrian area that allows pedestrians to move freely, pedestrians will always search for the shortest path from an origin to the destination. But before moving further, let's first put some labels on the origin destinations for better orientation. We can do this by adding a dynamic label with an attribute, and for an attribute we'll choose name. Okay, this goodies up the orientation now. So as I said before, the pedestrians will search for the shortest path between an origin and destination, which is available here in case of this route between Metro Inn and Camp Nou, because there is an existing pedestrian crossing, but it is not available for the route from Metro Inn and South Out within this pedestrian area. This is the reason why we need to add overpass or a footbridge with the use of the tool create level change object, and for this we can first switch to the bridges sublayer and activate it so that we place this object into this new sublayer. So let's create an overpass. Let's have a look in the details. So we can set the name of the overpass, the height, and also put some details about the staircases. So you can add more, or you can keep just one on each side. You can change the width of each staircase, and should there be more, you can also divide the flows by percentages if there are more staircases on each side of the bridge. Can also adjust the width of the bridge by dragging the geometry. Now we see it's beneath the road network, so to put it above in terms of visualization, let's head to the layer tab and let's change the pedestrian layer in terms of the level setting to a higher number. So adjusting this number elevates the bridge object above the road section so it gets visualized fully. At the moment, we have set all the minimum requirements for a pedestrian flow simulation, except for completing the traffic demand object by adding pedestrian demand item to the matrix. So let's open the traffic demand object and let's add an item pedestrian matrix demand. So we see there are total 700 commuters that will be simulated between 8 o'clock and 9 o'clock. Let's head to scenarios. There is a predefined dynamic scenario as a microscopic stochastic route choice experiment, one replication. With a right click on the replication, we can run an animated simulation. So this means there is a warm-up phase and then the simulation goes straight to simulating the pedestrians and of course motorized traffic. We can adjust a little bit the smoothness of the scenario and the simulation speed to have a good overview, and we see that there's already motorized traffic as well as pedestrians being simulated. If we zoom in a bit, we will see that pedestrians are taking both routes, so the one to Camp Nou Stadium as well as the one over the footbridge to the southern exit. Let's rewind a bit by either decreasing the smoothness or increasing the simulation speed and check the behavior. If we pause for a while, we can analyze the settings of the intersection. We see that the pedestrians are yielding to vehicles based on the signal plan information. So this node has a number of signal groups defined, and we see that there's also the pedestrian crossing in two forms, which is attached to one of the signal groups. And by clicking through the signal groups, we will find out that the pedestrian crossing is attached to a signal group 5. Looking into the control plan, so right-clicking on the intersection and looking into the editing tab of the control plan, we can check the phases which are attached to this control plan. And in the signal group 5, so the signal group linked to the pedestrian movement, is then attached to both phases 3 and 4. So the pedestrians will get in total 20 seconds green time in this control plan. Let's now talk about the interaction between pedestrian flows and public transportation services. In Aimsun Next, there are generally two options how to model this interaction, either by defining origins and destination and each public transport stop, or by using a new feature that has entered Aimsun Next release 20, which we call the dynamic public transportation assignment. And today I'm going to talk about the latter. You're encouraged to see the documentation for the description of the former approach. So let's dig into this modeling of dynamic public transportation assignment. For that, I would like to first enlarge the pedestrian area to cover at least 2 public transport stops, so that the pedestrians have the choice between walking towards their destination or taking a public transport line. For that, I will first deactivate the disabled object editing for pedestrian area and enlarge the area in a way that it covers 2 public transportation stops. For that, I can, for example, introduce few new vertices and the polygon so that I have stability when enlarging the pedestrian area. The same I will do in the southern part of the model. Let's then disable again object editing and switch to a Centroids sublayer and create a new pedestrian exit, which we can call courts out as the city district courts in Barcelona. So now we have a new pedestrian exit, and you can see that there is already a feasible path again from the metro in over this footbridge and then walking towards the destination. However, with the dynamic public transport assignment, the pedestrians also have the choice to taking the public transport from the nearest public transport stop, boarding the public transport service, and alighting again by the nearest station towards the destination. And the choice is really based on the cost for the trip, either walking or walking, public transportation service, walking again. So the cost is obviously composed of a few components, such as the travel time, of course, one of the most important ones, either for walking or for this combined trip. For the one with PT, then it's of course the waiting time component, if there is any transfer component, if we model any fare, and so on and so on. Now we have almost everything that we need to run the public transport assignment, except for the demand to the newly created destination. So let's put some example 300 pedestrians to the OD pair. And one last thing is missing, and that is activating the dynamic PT assignment on the experiment level. So if you head to Dynamic Experiment, Behavior tab, and the bottom of the page, you will find an enabling button to Dynamic Public Transport Assignment. It is also where you can define a flat fare or a transport penalty function for this public transport assignment. Let's then start the simulation and see how the pedestrians behave. We see that portion of the pedestrians decide to take the entire trip by walking, while other ones are motivated to take the PT line, board the PT line, and alight again and walk towards the destination. You can play around with, for example, the frequency of the public transportation service and observe how does the split between the walking and taking the public transportation service change. It is expected that more pedestrians should now take the public transportation service because the waiting time should be, of course, reduced by a higher frequency of the public transportation service. You can notice that pedestrians are walking over what is considered to be so-called greenery in the OpenStreetMap object list. If you want to prevent this, you have the option to create or generate obstacles based on the OpenStreetMap's imported objects. To do this, let's head to Layers and enable object editing, and let's investigate the different types of the OpenStreetMap objects. So the red objects are considered to be buildings, and those are the ones that are automatically defined as obstacles when importing it from OpenStreetMaps in Aimsun. These objects in green, the polygons in green, are considered to be a garden or a greenery, and these ones are not considered to be obstacles. If you want to change this, you can right-click on this polygon and generate pedestrian obstacle. So let's do this for the few objects that are on the paths for our pedestrians, and disable object editing again and see the result. Pedestrians are now still taking the shortest paths to their destinations, but are avoiding those polygons defined as obstacles. Let's conclude this video tutorial by color coding the pedestrians based on the ID of their destination. And to do this, we need to create a new view mode. But first, let us check in the table view the pedestrian centroids that help us identify those ID that are required for the creation of the new view mode. Okay, now we can head to view mode and with a right click create a new one and call it, for example, pedestrian destinations. Under use styles, please add a new style, and again let's call this destination style and look up for type object pedestrian simulator agent, and the attribute of our choice is destination. Since the Centroids IDs are of a discrete character, we can now create 3 new IDs, so 1517, 1518 and 1537, and assign a color rand of your choice to this view style. Now we have everything ready for the pedestrians to be color coded based on their destination and can change the view mode. So we see that the orange ones are heading towards Camp Nou, the green ones are heading towards South Out, and the red ones are heading to the Centroid course out, and that is either by walking directly or by taking the pedestrian transport and walking to the destination together. To wrap up this video tutorial, let's summarize what have we seen today. We've seen how to enter the minimal requirements for pedestrian simulation in Aimsun Next. So how to create pedestrian area, how to enter pedestrian demand in form of an OED matrix, how to create origins and destinations, how to connect pedestrians with public transport service, and also how to change view of pedestrians based on their simulator agent characteristics. That's it. We went through quite some parts, and now it's time for you to experiment even more with different settings and parameters and pedestrian types. If you are not sure about any component or about parameter, please feel free to consult documentation or write an email to our support on support@aimsun.com, and we will be happy to assist and provide you with help. So that's it for the moment. Thanks for watching this video, and see you some other time. Bye bye.